IoT devices are all the rage right now. These are devices that transform your home, your office, and indeed entire cities and industries into smart environments. But there's a problem. These devices need to be smart and secure. In this video, we'll discuss and show you how you as a device maker can achieve complete end-to-end chip-to-cloud security. Let's begin. As a device maker, security is probably one of your biggest concerns. If it's not, it should be. A compromised device can be harmful to critical operations or even harmful to health. Imagine for a moment a device that's part of the control system of your electrical grid in your region, or an autonomous vehicle, or even a pacemaker. IoT devices have become a favorite target of hackers. You've probably read or heard about such exploits in the news. Let's face it, no company wants to be the subject of an article describing in detail how its devices got hacked. It can have a lasting impact on customer confidence, brand, and revenues. So how do you solve this? To solve any problem, it is vital to understand it in its entirety. Security compromises can result from incorrect or bad choices during the design phase, which can leave the product vulnerable throughout its life. Another big concern is the potential theft or compromise of your intellectual property. This can happen at any time, but typically happens during the manufacturing phase and can often lead to clones of your product flooding the market and undercutting your opportunity. Lastly, once your product is deployed in the field, either in the home or a factory floor, you want to make sure that it remains secure and trustworthy for as long as it is in operation. Now that we understand the scope of the problem, let's take a look at what a trusted device looks like. What are its characteristics? For starters, all software that runs on the device must be authenticated. This includes the boot code and application software. The device itself must have an identity that cannot be spoofed. Most important, critical security assets must be isolated and protected at all times. Updates must be cryptographically authenticated, and lastly, devices must also be securely monitored. The two most important things to understand is that all of these aspects are chained together and that security must be designed in from the get-go. What this requires is selecting the right hardware platform with the right security features, implementing a trusted software architecture, and combining it with cutting-edge cloud services. So how does one get started? Any device design begins with selecting the hardware, which must be selected not only for its fit with its intended use, performance, power consumption, etc., but also for its security characteristics. Here, for example, we have the Shield 96 board incorporating a Microchip SAM A5D27 microprocessor. The chip embeds critical hardware features such as secure RAM, trust zone-based isolation, and hardware crypto accelerators, to mention a few. The chip is available both as a system on module or SOM, or a system in package or SIP, and provides a great set of advanced security features. So now that you've chosen the hardware, what's next? Your processor, while rich in hardware security features, needs software to take full advantage of it. This is supplied by Sequitur Labs' mSpark Security Suite. mSpark checks off all the boxes with respect to authenticating, protecting security critical assets, protecting intellectual property, enabling secure update, implementing failover and self-remediation actions, and even tamper detection. Another important feature of the suite is that it comes with tools to provision all firmware and applications securely during manufacturing in a manner that prevents software cloning and IP theft. In short, the suite provides all the underlying infrastructure and tools needed to achieve a trusted design. Okay, so you have basically completed the first step in your secure chip to cloud journey. The next step is to ensure that the device connects to the cloud securely, in this case, AWS. To do that, your product must be provisioned with the right cloud credentials and must follow the process laid out by AWS to enroll your device securely. Arrow's secure provisioning service works with Sequitur's mSpark Security Suite's provisioning tools to provision the right credentials during manufacturing. What this means is that when you power on the product, it will register itself on AWS and you can be assured that it will do so securely. With the device securely registered, you've completed the second step in the chip to cloud journey. The device is now ready to be managed. What does that mean? It means that it can now be updated securely and its health and behavior can be monitored. In this case, monitoring is accomplished via the AWS IoT Device Defender service, which monitors a number of cloud and device parameters known as metrics. This monitoring is further enhanced by mSpark Suite, which feeds in additional device metrics such as events. It also guarantees the authenticity of the reported metrics since they are collected, processed, and sent to the cloud securely. The combination of AWS IoT Device Defender and mSpark gives you the most comprehensive view into your device's health. Let's take a look at this in action. In this demo, we show a specific tamper event being detected by the mSpark Device Monitor service for a device registered on AWS. Here we have the Shield 96 board with a button. mSpark is already preloaded on this board and mSpark is actively monitoring tamper events, in this case, changes to the Linux kernel. Pressing the button creates a tamper event. Here, the button injects code into the Linux kernel, changing it. The board is already registered on AWS IoT Core, and its status is observed via the mSpark Device Monitor service along with other devices. Note that the status of the device shows normal. So let's press the button and initiate the tamper event. Upon pressing the button, the tamper event is picked up by mSpark, which sends a message to the monitoring service, which in turn changes the status of the device. mSpark also has the ability to initiate a remediation, in this case, to reboot the board into an alternate copy of a verified and authenticated kernel. Once the device reboots, the status will change back to normal. And that completes the final step of our chip to cloud security journey. In this demo, we used Microchip's SAMI 5D27 microprocessor with Sequitur's mSpark Security Suite and AWS IoT Device Defender. But this solution can scale to microprocessors from other vendors as well. For demonstration today, we used Arrow Shield 96 board, which is a versatile development board. The board is available for purchase today from arrow.com website. For more information on this video and to purchase the board, visit the websites shown here. Thank you for watching this video. If you have any questions about what you have seen today, please call or email us. Thanks.